We go. All right, friends, welcome. It's week 4, day 1. Second time doing the recording here. Just a little bit of housekeeping. We have a discussion question due at the end of this week. We have some core assignments. If we look here, we're on week 4. We have dojos and ninjas, and then books ERD. For this books ERD, all I need is you can do the ERD file or screenshot is fine, honestly. We're going to learn how to do that today. Now, Jeffrey, it might be a little bit different for you, but again, you have that video. I'm on my Windows computer, so some of my shortcuts aren't going to be, I'm not as good on the Windows as I am on a Mac. But yeah, that's what we're doing today. We're really kind of putting VS Code, we're putting coding away. Now, still practice it. We'll keep practicing it on Thursdays. But for the next couple weeks, we're going to be doing the next 2 weeks, we're really just going to be dealing with databases, what databases are like, how we can build them, how we can do that. And then next week, we're going to talk about database queries. So when we actually have some information, how do we go and retrieve that from a database? So it'll be really, really fun. I really like it. I think it's going to be awesome. So let's jump into that. And then again, the week 3 lecture recording from Nathan. Unfortunately, because he did have some issues with recording and he tried another method, but the other method did not record his sound. It's just his mouth moving, and that's it. So what I will do is on Thursday, instead of an algorithm, I will just do a little bit of a OOP sort of walkthrough because it seems like there's quite a few questions on it. So we'll make sure that we're all good to go and taken care of on that. Cool. Great. So today we're going to talk about databases. We're going to talk about key features of like a SQL database. And then we're going to create our first ERD. And all of this is going to be on the platform. We're going to be here. Get rid of that. We're going to now leave the Python fundamental section. We're now coming into this MySQL, MySQL or MySQL. And we're going to be here's your installation. Now, again, if you are on Mac and you are in Sonoma, I posted a video, like if your operating system is Sonoma, MySQL Workbench, the tool, the GUI, the graphical user interface that we're using is not compatible. And so I did put a video in our Discord channel that will allow you to basically walk through, one of our instructors walk through how you can create an ERD without MySQL, or kind of a workaround for it. I'm on my Windows today, so I'll show you how to do it. If you guys do have a Windows computer, we'll make sure that we use MySQL. Now, there is a little bit of, when I was doing it, I kind of redid it so that way I could be familiar. There's a little bit more to it than just this. When you click here, and it takes us to this website, you pick one of these installers. Now, normally, again, what I sort of look at is I say, okay, this is 285 million downloads or 2.1. And so I actually took this one, just this installer community instead of web community. I'm on Windows and I'm on version 8. Now, when you download, you're going to get that, and Oracle is going to say, oh, you have to sign in. You don't have to sign in. On the bottom, you can say skip. You get it. You're good to go. And then it's going to give you a couple different things. It's going to say, do you just want the server, or do you just want the other stuff, or do you want the full package? Make sure you get the full package, because what you want is a MySQL server, and you want a MySQL server, and you want MySQL Workbench there. So you want to make sure that you do that and get both of those things, because we're going to be using both of those. But you might be asking yourself, what the heck is MySQL? So here, yep, it's right here. You can see this whole full section. Again, you don't need to log in or sign up. You just click this no thing, start my download here. You can get all this good stuff, and it's all free. But you might ask yourself, what is MySQL? Well, when we're dealing with, I'm going to stop sharing here, and I'm going to go on to, I'm going to share screen and get a whiteboard. Cool. There's 2 types of databases, and I think this is really important for us to know, because you're going to deal with this at some point, and this is something kind of crucial information you need to be able to have. There are 2 types of databases out there. there are what we call a relational database, relational DB. And then there's what we call a non-relational. Okay. Your relational database is a database. Both of these are databases, both very, very popular. They both really have their own kind of not they have their own attributes and their own places where they exist. I would say that non-relational databases are kind of not taking over, but are really, really popular. Whereas relational databases are a little bit more, not old school, because they're still very popular, still very much so have their use. But non-relational databases are gaining in popularity. Some of the key things is with a relational database, the data, so I'm going to say data is what we call tabular, which just means it's in tables. So it consists of rows and columns. We're going to see all of this today. A little bit bigger, so it's on the same thing. Cool. Consists of rows and columns. And so every row must have a value in the column, or just at least must have that attribute. Okay, I think that's kind of good for right now. And when we're dealing with non-relational databases, so data and documents is just JSON objects. Let's get this a little bit bigger. Perfect. And then data consistency. This is, let's see. What I mean by data consistency is not as imperative is every time we have an instance in our relational database of a row, we're going to have rows and columns. Every row must have that column attached to it, right? Where if I've got a user, every user, let's say my attribute is first name, middle name, last name. Well, not everybody has a middle name, right? Well, still, even if my user doesn't have a middle name, it's going to have a middle name column, right? Even if there's no value there. Whereas a relational data or non-relational database is if you don't have a middle name, you just don't have a middle name. There's no value there. And so it gains a little bit of flexibility. Non-relational databases are becoming a little bit more popular. MongoDB really being one of the big ones, DocumentDB. Those are becoming popular because data is now cheap. Back in the day, data was really expensive. It was expensive to store data. You had to buy servers, you had to buy memory, you had to buy all this stuff. You had to hold it. You would have what we call on-premise, meaning that you had basically your servers, which are just computers, on your premises, on your building, or in your building, and you were having to maintain them. You had to have, there's a whole bunch of stuff that goes on there. And now with cloud development, with AWS, with Azure, with GCP, which is Google Cloud Provider, we don't have to deal with any of that, right? I can just send data and store it with AWS, which is the most popular. And that's really cheap. And so now that things are getting really cheap, it doesn't matter if it's, back in the day, whenever we had data, we wanted to make sure our data was good, wanted to make sure it was cleaned. Everything was kind of prim and proper because we didn't want to waste space, right? We didn't want to store things that didn't need to be stored that weren't of value. Now data is cheap. Things like an S3 bucket in AWS are dirt cheap. And so we don't care. Let's just store everything because the more data we have, eventually we might need that or we might use it or, kind of deal with it that way. When we're dealing with relational databases, really the big ones are going to be SQL or SQL. And then with that, you've got you've got, which is SQL query language. That's what it stands for. But you've got MySQL, which is what we're going to use. You've got Postgres, SQL. You've got a couple different other ones. But really, we're going to be using MySQL. Non-relational, you got MongoDB. You're not going to need to know anything about non-relational. I just wanted to give you that understanding because other classes take our JavaScript stack, which deals with the non-relational databases. You guys are not. So on the job, you're going to need to know what a non-relational database is. That's why I want to make sure I give you this information. Document DB. And I would really encourage you guys after class, dive into this, because not only is there non-relational databases, which is like from documents, but there's a whole bunch of like key values, there's graphs, non-relational databases, there's a million different types. CouchDB, go ahead.
Yeah, really quick. What about PHP? Is that what
PHP
kind
is
of
a language. What's a language? These are databases. PHP is a
Okay.
language itself, kind of like Python.
But it doesn't have anything to do with databases or anything like that?
It'll use a database. It's just like Python. So instead of doing Python, you do PHP. So just a language. Now, all
Okay.
of these databases can be used with any language, really. So you can use this with Java or PHP or Python or C# or JavaScript. There's lots of different versions or things you can use. Databases are pretty language agnostic. But they just operate and they all kind of have some similarities. So the ones we're going to be really focusing on, or the only one we're going to be focusing on, are these guys right here. This relational database, and specifically, MySQL. That's what we're going to be using. And so it's going to be a way that we can save data, right? We can now, when we're creating variables or we're creating users or we're doing something like that, we want to be able to go and retrieve that information. That's really all a database is. You can sort of think about it as like a vault, right? Where we want some data, we want to remember it, we want to be able to access it. And it's like, here's our secret vault that we can just put all of our information in. And when we need it, we can go to our vault and grab it. That's all a database is. From a very high level. That's really all it is. Okay. So again, I said that database or relational database, which is what we're dealing, is tabular, meaning that we are going to create what we call a table. Cool. This table is going to consist of a few different pieces, which is our information. So we are going to have, let's say that, let me move this color table. I always like to use Facebook because most everybody is at least familiar with Facebook. Maybe you don't have it, maybe you do. But we're going to create what we call a users table. A users table. And so what this is, it's a table, is this is going to be a way, if I'm creating something, if I'm creating a project, or if I'm creating a application and I want to be able to store user information, anything you can think about it in your real life, anything you log in with, that is user information, right? If you have a username and a password or an email and a password, there is some place that they are storing all of their users, right? It's a way that we can collect and say, okay, all my user data, I'm going to store it in this table. And what our table is really just a blueprint for how my data is going to look. It's just a blueprint for how my data is going to look. This blueprint is going to have a couple different key pieces of information. Really, there's 3 that it must have. And then there's like a little middle section that's kind of as much as we want. Cool. Does anybody know the first and most important piece of my user table?
ID.
Yeah, exactly. It's my ID. Now, this is going to be crucial for our database, and any database is going to have this. This is what we call it. Jeffrey, extra points. Do you know what the ID is called?
Um, like the definition or
Yeah, in my table, it's called a primary key.
primary key, yes. I do.
Yeah, so a primary key is really my unique identifier. I'm gonna put that over. You can sort of think about it as I've got a social security number. I was born here and I am a US citizen. And so with that, you get what we call a social security number. And my name is Will Calhoun, and there are other Will Calhouns out in America. I think there's actually one who's like a famous drummer or something. So it's kind of funny. Well, America, the US government, needed a way for me something to know if I'm applying for a credit card. I put Will Calhoun, which Will Calhoun is actually applying for this credit card. And so what they gave us is a social security number, and it is a unique number that is unique to me. So that way, when I am applying for something or doing something, they can identify it's myself applying versus somebody else, right? Same thing with applying for any credit or doing anything, going to school, whatever, right? It's the thing that separates me. There can be a lot of Will Calhouns, but there's only one Will Calhoun that has my social security number, hopefully, right? Or else I probably got jacked. And so in our database, this is what we call our primary key. It's always going to be ID. That is what we do. This ID, what will normally look like, I want this actually to be a little bit smaller, is
So it's
Perfect.
basically just an ID that a primary key is an ID that corresponds to a table.
that corresponds to a specific instance, and I'll get to it in just a second. But great question, Kevin. So I'm going to put 1. It is a numeric number, so something it can go all the way up to like this if you're on Facebook, right? Because they have so many users. But for right now, it's going to be the number 1. Now, this is always numerical for a relational database. For MySQL, it's always numerical. When you get into non-relationals, they can use letters and stuff. But it's numerical and it increments by 1. So we'll see whenever we get there, there's auto incrementing. And so what this does is this is, again, representing one specific user. The other 2 that we use that are crucial and key is we're going to have created at, and then I'm going to have updated at. Now, these are 2 timestamps that are going to allow us to know when this instance of a user, because we're creating our table, right? And each user within my table represents one instance. So it's going to know when was that user created. Or think about it like updated at. If I update my profile, I want to see when was the last time this user updated their profile. Think about passwords. And if a password needs to be changed every 90 days, this updated at could be something that we use and be like, hey, their profile hasn't been updated in more than 90 days, which means that their profile or their password wasn't updated. We might want to send them a push notification to update their password. So these are my timestamps. I'm just going to put timestamps here that allow me to handle some information. You can see it'll get really popular or it'll get really important when we're dealing with, I want the 3 most recent users. We can use timestamps to do that. Maybe you've been on an application or Facebook has said like, hey, you've been with us for 1 year. They know that because they look at the created at date, and a year from that day, they go, hey, congratulations, you've been a Facebook member for 1 year. So these are kind of our main 3 what we call attributes of each user that each user is going to have. right? And it doesn't matter normally what table we have. It doesn't matter if we create users or we're going to see comments here in a bit. They're always going to have some sort of primary key. And they're always going to have some sort of timestamps. This is your boilerplate. Whatever you create, any tables you create, it's going to have these three things. Then, what we have, I'm going to put this in green, is what we call our, I'm going to put this in star because this is not something we have. I just want to be able to distinguish between them. This is what we call our attributes. Now, this is something that can vary and change per table or per thing we're setting up. So in this case, we have a user. What are some things we might want our user to have? What should each user in Facebook have?
Name.
Yeah, exactly. Do I just want to put name or what can I distinguish?
name.
Yeah,
First name.
exactly.
Name.
Name.
So first name, and notice when we're writing our attributes, it still has the snake case, just like it does when we're writing variables. So same sort of thing there. And if you want to put F name or F name, that's okay. I like to really say it, but totally up to you. Maybe we have last name. What else might we have?
Email.
Yeah, exactly. Email. And maybe password. And maybe date of birth. Because we want to know, when was our user. Cool. And so these are the attributes of my user table. So each user is going to at least have every attribute when they are created. Again, maybe you think of like Seal, the singer Seal doesn't have a last name, or Madonna doesn't have a last name. So maybe they will have an empty last name, but there's still going to be the last name attribute there. Right? It just might be empty. So these are my attributes here. Now, normally it's going to look like just flush, and you're not going to have like attributes with these spaces, but you can see this. Now, this is one thing I really want to point out. Just make sure everybody gets this. This is
Is
my
that in?
users table. These things here, I'm going to do this, but please don't mind the email, how it bleeds over. Pretend that email was outside of there. These are my attributes. Right? Same thing with ID. Each user is going to have those attributes. The stuff on the right represents the values of a particular instance or a particular user.
So, so you're saying the ID one, right? The attributes, the first name, last name, email, created at, updated at, those are like a hard code that will never change, but the information on the right side will always change because obviously it's
Yeah.
gonna be different users in it.
So exactly. So every user that signs up, we are going to create, it's going to look like this, right? When, let's say, Jeffrey signs up, Jeffrey's information is going to be there. In my database, it is going to be something like this. And it's going to have a whole bunch of lines. and it's gonna have ID, and then it's gonna have first name, last name, what do we say? Email, password, date of birth, created at and updated at. Okay, but it obviously it'd be normal. And so that's what it would look like, right? Here would be my header. They would have all those. Then, and I'll change the color to show. Jeffrey signs up, and this whole first row between here and here, this orange is Jeffrey. Then Kevin signs up, and this whole portion here is Kevin. It's an instance. So let me point. I'll say,
And each row has a first name, last name, email, password, and DOB.
yep, exactly. They all have the same pieces of information.
It's kind of like where, say, if there's like a fitness club and you sign up for a fitness club, there's a whole database that has the information for each member of the fitness club, and it's all in the database of the website of the fitness club.
Exactly. Exactly.
It's just a
So-
simple Excel sheet.
Exactly. That's basically all a database is. And so some companies will actually use Excel as a database, which is not great, but it's really all it is. And so you see that, if I had ID, like ID here, and I'm going to put F name. It's really all it is. But the thing I want to reiterate, actually it was, yeah, is this is you can see this is what we call tabular. This is our tabular data. It's got rows and columns. That's it. Just like you said, so just like an Excel sheet. Each
So-
one of these. Just real
Sorry,
quick.
you said each row was instance?
Yeah, that's what I was just about to say. Each one of these represents an instance of my user. An instance of my user. So, Jeffrey would have the ID of 1, Kevin 2, Strella 3, Will 4, etc., etc., etc. Now, are there any questions on that? And then we're going to kind of take it up a step. Does that make sense?
Yes, it makes sense.
Cool.
Yes.
Okay. Now, going back to our Facebook example. Users don't just create profiles and that's it. They can do other things, like creating a comment. Maybe there's a post, right? And on a post, they can have, maybe we'll do a post. Yeah, we'll do a post. So we'll say posts. And it is normally plural. So whenever you're creating your table name, it's normally plural. Now, this is going to have, what are my 3 main things that this is going to need to have? Anybody remember?
You said an ID,
Yep.
the primary key, and the timestamp?
So the primary key is my ID,
Okay.
but you were pretty close. It's a timestamp. It's the created at.
They updated that.
Yeah, exactly. And the updated at. These are my main 3. This is my boilerplate. Now, what is on a Facebook post typically? You've got maybe the content / message. What else? Maybe a location. Sometimes they do that, right? They do a location.
Yeah, those people like to post everything.
Yeah, they do. Maybe there's like an image.
music, the music now.
Is there a music thing? Music? Sure.
Actually,
That's
no. No, I
Yeah,
think
I like it.
the content has music, but yeah.
Yeah, we'll keep it. We'll keep it.
Okay.
We'll just say that we'll call this text. Oop, that's one of those things that I would have been able to do on Mac. Okay. So
Oh, don't hate on the PCs.
I know. I know. Okay, so each post is going to have an ID, right? Because each post is a different instance. It's going to have some sort of text or message. It's going to have a location, an image, we're saying music, created at and updated at. Now, the idea behind a relational database is we can create a relationship between two pieces of data. Two pieces of data. Now, the way we do that, and we think about this from a Facebook perspective, can a post exist if no user created it?
No.
No, right? Something had to create that post. So we can say that this is reliant on another table. And so what we will do is we will have another field called user ID. And it's the singular version of whatever the table is called. So if this is users, this is user. And then their ID, again, their unique identifier. That's going to be the thing. ID is always going to be the unique identifier. That's always what we relate. This allows us to know which user posted this post. Now, can multiple users post the same post? And I'm not talking about reposting, but can many users post the same post?
I'm confused. I'm confused, Will.
Okay.
Can you repeat that, Will? Let me
Yeah,
know.
Yeah.
let me come back. Let me come back. Anytime a post exists, we know that a user has to create it. A user can create many posts, right? Like I can post every day, like Estrella was saying, I can go every day, I can do 20 times, I can do every minute of every day, I can do a Facebook post, right? But each post can only have one user who created it. Does that make sense?
Correct. The
Yeah.
person that's creating it.
Yeah, exactly. So that is what we call that relationship where the user can post many posts or can write many posts, but the post can only have one user associated. That is what we call a one-to-many relationship. And it looks like this. Comes here, and then we're going to have a line here and a line here. That's what we call a one-to-many relationship.
Okay, so I'm just gonna kind of go back. So the ID or the attributes, like when you're actually creating the account, right? The users.
Mhm.
This is one database or this is just part of a database?
This is all part of the same database, and the database is made up of many tables. Think about it's one Excel workbook with many tabs.
Okay, okay. And then, so now this Will, sorry, Will has, now that his account is created, now he is creating posts. But because he's the one that created it is why it's his, like, connected or his relationship or what, trying to figure out like another word to explain it.
Because if a post is created by Will, this foreign key is what associates and says, Will, the user with the ID of 1, which we would then look up and say, oh, that's Will. They're the one who created this post, this instance of this post. So if we go back to, think of our table, let's say we had our post table, there'd be a little column of user ID. This is what associates when Facebook, whenever I post, just ate at McDonald's with my dog, and it shows up my profile picture and it shows up my image and it shows up on my profile and it's associated to my account. It's because of this right here. Because we established a relationship between one piece of data and another piece of data. The post cannot exist without a user. So we have to put on the piece of information that needs or that cannot exist without the other, that's where the foreign key lives. So, which is my user ID. So when I create a post, it associates that I'm the one who created that post for that specific post.
Excuse me, Will. I have a question.
Yeah, go ahead.
With the relationship, I mean one to many.
Mhm.
Where do we click? Where do we click first? Is it the post or the users? Since it's like one user and many posts.
You mean when you're creating your ERD or when you?
No, when we are connecting the relationship.
I think you go many to one.
Oh,
So
so
like if to make it look like this.
yeah.
Yeah, I think you go many to one, but if not, do the I don't remember off the top. But we'll test it here in a second when we do this on MySQL Workbench.
Oh, okay.
Yeah,
I have a question, Will.
go ahead.
So since we're talking about Facebook, so we created this post.
Mhm.
Now, will it be the same way when people tag somebody? Does that create an additional ID, or does it just stays as yours because you're the one that's creating it?
Great question. It would stay as yours, but you would have maybe something like tagged user. This would just be, let me actually take this up because I don't want to confuse you. I like to distinguish between the created at and updated at. It's kind of the end. You would just have another field called
Gotcha.
tagged users that would maybe have, then it would be the tagged users IDs there, but the relationship is not
Okay.
with tagged users. It is with whoever created it.
Gotcha.
In this case, what?
Okay. I
Great
understand.
question though. Cool. Okay. Now, we got 15 minutes left, so we'll talk about many to many. Actually, we could do this real quick. There's another type of relationship called many to many. And so if we think about it, let's pretend that I have another box called likes. It's going to have an ID. Maybe a created app, updated app. Now, can many users like the same post?
Yes, they
Yeah,
can.
they can, right? So we have our user ID. And can a like be can a post have many likes?
Yes, it can.
Yes.
Yeah. So this is what we call a many to many relationship, where I'm creating up an instance where many users can like many posts, and a post can be liked by many users. And so this is what we call a many to many relationship. We're gonna, if this doesn't make sense, we're gonna build into it. So don't worry, really just focusing on one to many right now. But just wanted you to know that this is another relationship that we will get to called a many to many. Where then we have the same situation where we've got this like this, or we have it here. And then another one. It's kind of connecting the two. It's called a many-to-many relationship. But that really the only thing is, yeah, now we have two foreign keys here. User ID and post. It doesn't matter which order they're in either. But we have two foreign keys here. Okay. I'm going to save this and put this in our Discord, just so you guys have it. Okay.
Perfect. Because I'm over here drawing like you.
Yeah, good. No, I'll make sure that I save it and you got it. Okay. Let me pull up my SQL workbench. And then we'll actually build this out. Okay. So let's share my screen. Okay. So this is my SQL workbench. Again, Jeffrey, I'm so sorry, but you know, we got you all set up. This is what it's going to look like when you get all set up. You're going to have this, and this is a GUI, a graphical user interface that allows us to interact and build without writing code. Now we can write the code, just SQL code, and I'll show you what that looks like at the end. We might go over by about 5-10 minutes, just a heads up. But I want to make sure you guys get this. I really wanted to go in depth there. But this is what it'll look like. And you can create ERDs here, or a table is what we call a model. So same thing, when you hear model and table, they're kind of created the same way. And here we have our databases. So the way that you're going to operate it is you're going to go to your instance. And so instance just means that I've got a SQL server running. Now, relatively, it's kind of the same as if I had it in the cloud. It's just some computer somewhere running this code. So I have this instance running. It's going to ask me for my password. Perfect. And now I have entered into my SQL databases, or database. My SQL server, sorry, not my database. This is my SQL server that can have all of my databases on there. I don't have any yet, but I can do that. Cool. Now, when I come here, I can create a new model. And this is what your first assignment is going to look like. You're going to need to come here. Just come to these three little things. And we're going to create a new model. And so this is what it's going to look like. We're going to change our database. So we're going to call this DB intro. And again, we don't want to have any, spaces or anything. Do the underscore. Cool. So I've changed my name. We're good to go. And I'm going to click this add diagram here. And we're basically going to create the same thing as we just did, on the, what's it called? Sorry.
The whiteboard?
Yeah, thank you. Thank you, Cheryl. It's been a long day. Okay.
It's good.
Cool. So cool. We're in our DB. This is my actual database, DB intro. And so what I want to do is I want to create a new table, right? I'm going to create a new table. So let's just kind of look at this. Here we have place new table or new view, which we don't need to, or new routine. So let's go to this new table here. Cool. We're on our new table. Now we can see we're in tables. We have table 1. Remember, what did we want to call this? My users table. Cool. This is now my users table, and you can see it's updated here. And so all I need to do is I need to go through and create the same attributes that we had. So again, we have our column name. So I'm just going to call this ID. Now, each attribute, we didn't do this on our kind of layout because it wasn't necessary, but we have to store or tell our database how we want it to store each piece of information. And that's in, basically what data type do we want to store it in? There's lots of data types. Click here, you can see there's lots of data types. So let's go through just a couple of them. Really, the big one you're going to use is int. That's just like a normal integer number. You're going to use varchar. That's character. Think about any sort of string. You're going to use date time. And that's kind of it for right now. There's also like long text and medium text. Now, the reason you want to do this is, or the way you could, we're just going to use varchar for strings, but it allows us to make sure that before people dominate our database or take up too much storage, we put some parameters and say, okay, you can't store all 7 books or 8 books of Harry Potter as the name because it's going to take up too much space, right? So we can limit the amount of characters there are. That's where varchar comes in. And so same thing with like long text, medium text. And there's like big ints. So if you have certain numbers that go above, I think it's like 256, but don't quote me on that. We need to again say, okay, we need to handle this in a different way. And that all has to do with memory and binary. So it's way too in the weeds, but just know that there's a couple different ways we could do it. Blobs would be like an image is stored as a blob. But really, again, the main ones you're going to deal with are these top 5. If you're not going to have to deal with blobs here. I don't even know that you'll have to do decimals. But so these top 5. So ID is a database. Now, there's a couple different boxes we can click. And if you don't know what they are, you don't remember it, you can just hover over. PK stands for primary key, meaning, that is our unique identifier, our primary key. So anytime we have our ID here, that is what we click. NN is not null. So meaning there has to be a value here. Like I said, an instance can have an empty field of like name. Let's say they don't have a last name or they don't have a middle name. That's okay. But for an ID, it can't be empty, right? We have to have that unique identifier. It has to be a number associated. So anything that is really crucial for us to be able to use, let's say, an email. They have to have an email if they want to sign up. We have to be able to know that information. We might put not null there. There's a couple of other ones like unique, binary column, a couple different other ones. But the other last one to know that's really important is that for your primary key, you always want to do this AI, which is auto incremental. So what that means is it's going to start at 1, and then the next instance that's created will go to 2, into 3, into 4. What's also really important about that is that it does not backtrack. And this is really something to know is, let's say that I sign up. I'm the first ever user for Facebook. So I have ID of 1. And I use it for a year, and now there's 1 million people using it. Let's say I want to delete my account, and I delete all my information. I fully delete my account, no recovery. Well, technically, there's no user associated to the number 1. But for data purposes and to make sure there's not any sort of issues ever, and for like data security, you cannot backfill. So they're not going to backfill and say, okay, the 1 millionth in one customer or user is now just ID of 1. They don't do that. So once that ID is used, it's not used again. And so this other incremental will make sure that that doesn't happen. Cool. So let's just kind of go through a couple of these. We have our first name, varchar, and then so in varchar, it accepts an argument up to 255, I believe. And this is how many characters can be there. 45 characters feels pretty okay. I've never seen a first name with more than 45 characters, so that's a-okay. It's not a primary key. It could technically be null. Cool. We have our last name. Varchar, great. We said that it was an email. Maybe we'll go up to like 65 because some people have super long emails, or maybe even 85. That's a-okay. Maybe last name, we can go up to 55, just in case somebody has a long name. Maybe we had a password. Again, varchar. Now, with passwords, we will eventually, give me 1 second,
Sorry.
we will, no, you're fine. we will eventually hash these. And so really hash is just saving them like encrypted. And so normally what I like to do is go to like 65, just in case we do an extra long hash, we don't run into that issue. Go ahead, Estella.
So you're just filling them all out right now, and then you'll pick whether they're null or all the other boxes to the right.
So this is just us creating and setting up the table.
Okay, so like, you know how you have like the primary key and then the null, and we don't have to select any of those boxes?
Nope,
Is
because
my
we're
question.
saying, maybe we're saying, okay, they have to have a password. Okay, that can't be null. They have to have an email. It can't be null. Okay, that's fine.
So null means what? Like it has to have it?
Not null means that, yeah, so null is just that there's no value there, right? They don't have a last name. That's okay, right? There's still the last name attribute. Like I said, remember it's tabular. So every instance has to have every single one of these. It's still going to have a last name. It's just going to be null, meaning that there's no value there.
Okay.
Not null is saying, hey, it's not okay. You can't save that information. We need to give an error if they try to save an instance that doesn't have an email. It cannot be null. It has to
Okay.
have a value. Yeah, so that's what that means.
Understood. Cool.
Yeah. And so really the only one is not null that you're going to deal with, and then auto increment and PK just for your unique identifier. And then I'm going to come here. I'm just going to say timestamps. Oops. Okay, so we can just do this. So we can do created app. But it's not going to be a data type of var chart. We're going to go to date time. And then we have an updated app. That's also going to be a date time. Cool. And I think the default expression is like current. Oh, here's what it is. Oh. Now this one, so for our updated app and our created app, we could do this current timestamp, and that'll take just the exact timestamp at that time. So that's what this default, and what this will do here is when it's updated, it'll take the current timestamp. What this does is when we're actually creating our instance, we're going to give some information and say, okay, the first name is Will, the last name is Calhoun. And so what I could do if I had this empty, which it would still work, is I would just have to give a value for this, right? Because they cannot be not null. So I'd have to give a value for like datetime.now. But what this allows me to do is it automatically does it for me. It's really just a shortcut. So whenever I'm coding later on, it's a little bit easier. Okay. So I've got my user table. I've got my user table where I've got int, first name, last name, email, password, created at, updated at. These are both date time. We are good to go. Now the other table, and I'm going to kind of speed through this, that we wanted to create was posts. Now, it was going to have an ID. That's going to be a PK and auto incrementing. Great. And we're going to say content, varchar. Now post can be a little bit long. So let's go 255. And then we'll have, what did we say? Location. We'll just say for right now, it's maybe 255. Maybe they want to do some sort of, kind of ping where they're at. Maybe we just have like image. Just like I said, it's gonna be a blob. We have a created at. Take time. Not null. Oh. Okay.
This seems kind of tedious, Will.
It is tedious. Just so you know, there's typically, this is somebody's job. You won't really have to do this very often because somebody's job will be like database administrator. Because DBs are like where all the money is. Data is money. Okay. So now we've created these two instances. Last thing I want to show you is we can create a relationship by coming here. Let's get rid of that. And here's all of our ones. We have a 1-to-1, a 1-to-many. So N always typically represents like many, so it doesn't matter how many there are. Another 1-to-1, 1-to-many. This is non-identifying. This is an identifying. And then N to M is our many to many, because there's N numbers of users to M numbers of posts. So we're going to grab this. Oops. I went the opposite. I literally told Jeffrey.
Oh yes, that's what I wanted to know actually. Yeah.
Yep. So you come to the mini to the 1. And it
Oh,
creates my relationship. Right? So you got my mini. So you throw the way I think about it is the little M. It's a little trident, but I think of M as mini. Like that's
Yeah.
on the mini side. And that's just there's nothing there. But you see that it automatically created my user ID, users ID. So actually, let's go in and call that ID, user ID. Automatically created that for me. So now I have that. And here, the last thing I want to do is when I have this foreign key of user ID, when I delete, I want to on delete cascade. Now, what that means is if my post cannot exist without a user, if my user is deleted, I want to delete all the posts too, right? Because it can't exist without a user. It doesn't make sense. So I go into foreign keys, get my user ID, and then I say on cascade or on delete cascade. So if the user is deleted, delete my post as well, or any post associated with that user ID. Okay. Yes, this does feel tedious. We'll get really fast. I went really slow there, but it does get really fast. And you can do like what I didn't do is, I could do something like this. Since it already has a lot of the stuff. We could have just gone in and edited that. See, it already has a lot of that built. So, but you'll get used to it. Now, last thing we'll do is we'll come here. We'll come to this database. I couldn't remember which tab it was under. Come to this database, and we're going to forward engineer. So we created the instance. That's fine. Okay. We've created what it looks like. Here's the SQL code. Like I said, we don't need to use the GUI. We could basically do it here, where this is actual SQL code that it's going to run. And what that's going to do is this is going to create my actual database. Right? So I could have written this, but the GUI is a little bit easier. Okay, close. Cool. So now I should have that. Let me look, try to find it. But any questions so far?
I have a question with yes.
Yeah,
So we save it and then we forward engineer, or we just forward engineer?
I would save it first. You want to save it, like I would file save model as, or save model, because then what happens is, let's say that I fudged up and said, you know, I did last name, but this way. When I go to save my data, I'm like, oh no, my data is not saving. Why is it not saving? And I see like, oh, because I'm trying to add into last name, but I did last name instead of last name. But if you have it saved, you could just go change it, you know, open it up here, change it, and then forward engineer it again. And then now your databases could be updated.
Oh,
So you want to save it. That's a great question. Save it. And then you go to database, forward engineer, then you forward engineer it. We'll get a lot of practice with this. I know I gave you so much information. I'm going to pause there. Are there any questions on what we did here?
No, not at the moment.
Okay. We'll get more practice with this. So if this was, I know this was a lot, it's a big lecture. But we'll get more practice with it as it goes. So, okay, I kept you guys 8 minutes over. I'm so sorry. I'll stop the recording here.